Let's continue with the second part of this story. If you haven't listened to the first part yet, visit my channel and check it out first. Lakes played a similar role. East Africa's Great Rift Valley contains some of the largest, deepest lakes on Earth. During wet periods, these lakes expanded dramatically, creating huge, productive ecosystems that could support large human populations. When the climate dried, the lakes shrank, forcing populations to either adapt or migrate elsewhere. This cycle of expansion and contraction created exactly the conditions for rapid evolution. Isolated populations adapting to local conditions, then reconnecting and exchanging their accumulated adaptations with other groups. Coastlines were perhaps most important of all. Africa has over 18,000 miles of coastline, and coastal resources are uniquely stable compared to inland environments. When droughts devastated the interior, coastal populations could survive on shellfish, fish, and marine mammals. Archaeological sites along both the Atlantic and Indian Ocean coasts show continuous human occupation through periods when the interior was largely empty. These coastal populations became refuges, genetic reservoirs that preserved diversity even when climate disasters struck inland regions. The genetic evidence supports all of this beautifully, though it took decades for scientists to fully understand what they were seeing. Early genetic studies showed that modern humans have unusually deep population structure within Africa. What this means is that different African populations are genetically more different from each other than they should be if we all descended from a single recent common ancestor. Some African groups separated from each other over 200,000 years ago, perhaps even longer. That is not what you would expect if modern humans emerged from one small population around 150,000 years ago. But it makes perfect sense if modern humanity emerged from a network of populations that were already partially separated from one another. The Sand people of southern Africa, the beauty of the Congo rainforest, the highlanders of Ethiopia, these groups showed genetic signatures of ancient isolation. They were not completely isolated. Of course, there is clear evidence of gene flow, occasional mixing that kept them all part of the same species. But they spent long periods evolving independently, accumulating their own unique genetic variants. This is why some geneticists now talk about structured populations and metapopulation dynamics when discussing human origins. We were not one single population. We were a network. Individual nodes in the network would grow, shrink, sometimes go extinct. But the network as a whole survived, and more importantly, evolved. When populations reconnected after periods of isolation, they brought together different evolutionary experiments, different solutions to the problem of being human in Africa's wildly diverse environments. Perhaps one population had evolved better resistance to tropical diseases. Another had developed more efficient thermoregulation for hot, dry climates. A third had larger brains or better language capabilities. When these populations mixed, their children inherited advantageous traits from multiple different lineages. This is called admixture, and it is incredibly powerful from an evolutionary perspective. It creates variation much faster than mutation alone, giving natural selection more raw material to work with. The cycle of isolation and reconnection may have been the very engine of our evolution. Not steady, gradual change in one direction, but punctuated bursts of innovation as populations came together, mixed, and created novel combinations of traits. Think of it this way. Evolution through isolation gives you specialized adaptations. Evolution through mixing gives you versatility. The populations that eventually became modern humans got both. They were specialized enough to thrive in specific environments, yet versatile enough to adapt when conditions changed. This explains something that has puzzled anthropologists for many years. Why did behaviorally modern traits appear sporadically across Africa before becoming universal? Archaeological sites show sophisticated stone tools appearing 300,000 years ago in some places, but not becoming widespread until much later. Symbolic art shows up around 100,000 years ago in South Africa, then vanishes, then reappears somewhere else. Systematic use of fire, complex hunting strategies, even burial practices, all appear and disappear across different times and places. We used to think these were false starts, populations that almost became modern but did not quite make it. Now we understand they were simply part of the network. Individual populations developing modern behaviors in isolation, then either dying out or mixing their innovations into the broader gene pool when reconnection occurred. The traits that spread were the ones that worked in multiple different environments, the ones that got selected for again and again in varied contexts. Humanity did not emerge from one place. It emerged from many places, many populations, all evolving together across an entire continent. We are the product not of one successful experiment, but hundreds of experiments running simultaneously, their results mixing and remixing over hundreds of thousands of years. Every modern human carries genetic heritage from multiple ancient African populations. We are all mixtures, all products of that vast continental network that kept trying different solutions until it found combinations that work nearly everywhere. The beautiful complexity of it takes your breath away once you see it clearly. Not one garden, but a whole continent of gardens, connected by rivers and trade routes and marriage exchanges and slow, patient gene flow. This is how we became human, not in one place, but everywhere, not in one moment, but across hundreds of thousands of years. Africa did not simply give birth to modern humans. Africa was a womb itself, vast and complex, where we grew slowly from many seeds into something that could eventually walk out and inherit the earth. Now let us return to that small group stepping out of Africa around 60,000 years ago. For a very long time, that was a clean dividing line in the story. Before 60,000 years ago, humans were in Africa. After 60,000 years ago, they left Africa and spread across the rest of the world. Simple, elegant, easy to draw in a textbook diagram, with arrows starting at one point and radiating outward. But nature does not like clean lines, and human evolution especially does not. As scientists dug deeper into the rocks and the DNA, the neat picture began to blur. Evidence started appearing that seemed wrong. Humans outside Africa long before the supposed big exit. Fossils that did not fit the expected timeline. Bones that looked like ours. Found in places, and at times where they simply were not supposed to be. The first big crack in that 60,000-year wall came from a cave on the eastern edge of the Mediterranean. Messier Cave on the slopes of Mount Carmel in Israel. Inside that cave, archaeologists found a partial upper jaw, just a fragment with a few teeth still rooted in place. At first glance, it did not look like much, but when specialists examined it, they realized this was not Neanderthal. It was not some earlier hominin. It was us. Anatomically modern Homo sapiens. And when they dated it, the numbers came back like a thunderclap, about 180,000 years old. That is more than 100,000 years before the main out of Africa migration was supposed to have happened. For decades, the story had been that modern humans only successfully expanded out of Africa around 60 or perhaps 70,000 years ago. But this jaw said something very different. Humans like us were already in Levant, living in caves above the Mediterranean 180,000 years ago. They were hunting, making tools, building fires, leaving ash and stone and bones scattered in layers. They saw the same stars that would guide sailors in caravans many millennia later, and then they disappeared. Their genes, as far as we can tell, do not make a major contribution to modern non-African populations. Welcome to Sleepy Time Stories. Hey, dear friends, let's continue with the second part of the story, the real story of Out of Africa, why 300,000-year-old Moroccan fossils changed everything. History for sleep. If you haven't listened to the first part yet, visit my channel and check it out first. This suggests something important. The world outside Africa was not discovered just once. It was visited, explored, colonized, lost, and rediscovered over and over again. Messier is not some strange exception. It is one clue in a growing pattern. Travel west in your mind, across the Mediterranean, to the rugged coasts of southern Greece. There, in a place called Epitome Cave, a team of researchers working with some old museum fossils made another unsettling discovery. Fragmentary skulls had been collected from the cave decades earlier and then largely forgotten, stored away in drawers. When modern dating techniques were finally applied to them, one of those pieces, called Epitome 1, gave an astonishing result, roughly 210,000 years old. And its shape was more rounded at the back, more like a modern human skull than a Neanderthal one. Not a perfect match, not a complete skull. But enough that some researchers argued this might be an early Homo sapiens in Europe, over 200,000 years ago. If that interpretation is correct, and not everyone agrees, it means humans like us briefly reached southern Europe long before the Neanderthals' supposed monopoly. They came, they lived there, and then they vanished, leaving the continent once again to their cold-adapted cousins, Messia in the Levant, Epidema in Greece. Together, they whisper the same thing. Out of Africa was not a single, heroic march. It was a stuttering, complicated process. A pulse, then another pulse, advances and retreats, migrations that flourished for a while, and then ended in silence. Some of those journeys left little or no genetic trace in modern people, evolutionary dead ends. But they happen, they are part of our story. And then, as you drift further east in your imagination, past the deserts, across the mountains of Central Asia, there is another player waiting in the darkness, a cousin we never knew we had, whose face we still do not truly know. The Denisovans, their entire known fossil record as of now, could fit quite comfortably in the palm of your hand. A few teeth, a pinky bone from a little finger, a jawbone from a high-altitude cave on the Tibetan plateau. That is all. No complete skull, no full skeleton, no dramatic, Lucy-style discovery to put on a museum poster. If you walk past a Denisovan in the street, we do not actually know what you would see, but their DNA, that is everywhere from Siberia to Pacific. Their ghost is in our genomes. It all started in a cave in southern Siberia called Denisova Cave. Archaeologists have been excavating there for many years. They knew Neanderthals had lived in it. They knew modern humans had visited. It is a kind of crossroads cave, a place where multiple human species passed through over thousands of years. Then geneticists sequenced the DNA from that little finger bone. They expected Neanderthal, or perhaps modern human. What they found was neither. The genome was human, but different. Closely related to Neanderthals, yes, but distinct enough to be its own lineage. Another branch of the post-bottleneck radiation, a sister species. Not quite us, not quite Neanderthal. Something else. The Denisovans have been there all along, invisible, hiding in plain sight until genetics turned on the lights. When researchers started looking for Denisovan DNA in living people, they found it in a very particular pattern. High levels in populations from Melanesia, New Guinea, parts of the Philippines, and some indigenous Australian groups. Lower but still detectable levels in parts of East and Southeast Asia. That distribution tells a story. It suggests that Denisovans were not simply sitting in one Siberian cave. They were spread across vast stretches of Asia, adapting to different climates, interbreeding with incoming modern humans more than once, in more than one place. In Tibet, their legacy is written in the blood. A gene variant called EPS1 helps people cope with low oxygen at high altitudes. It allows modern Tibetans to live, work, and raise children on the roof of the world without the dangerous side effects that lowlanders often experience. Genetic studies show that this variant does not come from ancient Africans. It does not come from Neanderthals either. It comes from Denisovans. Thousands of years ago, modern humans moving into the high plateau interbred with Denisovan-related populations that were already adapted to thin air. Their children inherited Denisovan survival genes. And those genes are still at work today. Quietly, every time a Tibetan walks through the streets of Lhasa or climbs a high pass without gasping for breath. Neanderthals left similar traces, just in different parts of our biology. Genes that tune our immune system, genes that affect skin and hair, genes that may influence how we respond to certain diseases, or even how we sleep. This is not a story of simple replacement. It is a story of absorption, entanglement, and blending. For years, the dominant narrative was that modern humans left Africa, met Neanderthals, and replaced them. End the chapter. But the DNA tells a far more intimate tale. When modern humans spread into the Middle East and Europe around 60,000 years ago, they did not simply compete with Neanderthals. They lived alongside them, learned from them, borrowed tool ideas, possibly shared hunting grounds, and at least sometimes, They had children together. We still do not know exactly what those meetings were like. Were they mostly peaceful, small groups cautiously trading and occasionally forming mixed families? Were there also conflicts, violent encounters over territory and game? Almost certainly there were both, because human history has always contained both cooperation and competition. What we do know is that interbreeding happened multiple times. Genetic studies show that people whose ancestors lived outside Africa carry about 1 to 2% Neanderthal DNA. Some populations in Asia and Oceania also carry Denisovan DNA, adding yet another layer. There are even hints that Neanderthals and Denisovans interbred with each other as well. A bone fragment from Denisova belonged to a young girl whose mother was Neanderthal and whose father was Denisovan. She was literally a hybrid child of two different human species. If you imagine all these interactions unfolding over tens of thousands of years, you start to see why the old, clean model breaks down. Humanity's expansion out of Africa was not a simple replacement wave, washing over everything in its path. It was more like a series of tides, each one rising, falling, mixing with what had come before. Some waves left deep marks in the sand of our DNA. Others surged, then receded, leaving almost nothing behind but a fossil and a cave wall and a mystery for future scientists. And while all this was unfolding, Asia itself was already a crowded stage. Long before modern humans arrived, Asia was home to other human species. Homo erectus had been there for more than 1 million years. Sturdy, long-legged travelers who first carried a human lineage out of Africa into places like Java and China. In some regions, they held on surprisingly late, perhaps until around 100,000 years ago. Then there was Homo floresiensis, the hobbit of the Indonesian island of Flores. 3 feet tall, with tiny brains but surprisingly sophisticated tools. They hunted dwarf elephants and giant rats on an island that seems to have its own little evolutionary fairy tale. They may have survived until as recently as 50,000 years ago, right around the time modern humans were sweeping through Southeast Asia. Elsewhere in the region, in the Philippines, another small-bodied hominin was discovered, Homo luzonensis, with its own strange mixture of ancient and modern features. It adds yet another layer of complexity to the map. So as modern humans moved eastward from Africa, they were not entering an empty world. They were stepping into a continent already populated by multiple kinds of humans, erectus like holdouts, Denisovans, little island specialists like the hobbits and Homo luzonensis, and further west, the Neanderthals holding their icy fortresses in Europe and Western Asia. The old picture showed one line leaving Africa, one big arrow spreading across a blank map. The new picture looks more like a tangled web, multiple exits from Africa at different times, some early, like Messier and perhaps Epidema, pushing into the Levant and southern Europe, then failing when the climate shifted or competitors pushed back. Later waves around 120,000 years ago, leaving traces in Arabian stone tools. The final big wave around 60,000 years ago, the one that did stick, mixing with Neanderthals and Denisovans, skirting past hobbits and other island oddities, and eventually circling the entire globe. Out of Africa did not happen once. It happened again and again. Sometimes it worked. Sometimes it did not. Each attempt left fragments behind. A jaw here, a tooth there, a segment of DNA preserved in the cells of people who would never know they carried ghosts from Siberian caves or high Tibetan valleys. As you lie there listening, you can think of our species as a traveler who kept approaching the door to the wider world. A few times we opened it, stepped out, walked a little way, then turned back or were forced to retreat. Other times we stepped through and stayed, weaving ourselves into the lives of the people already there. Neanderthals with their heavy bones and big brains. Denisovans on their mountain plateaus. Island dwarfs on forested volcanoes. Only one of those human lineages is still here in full form, but the others are not truly gone. They live on as whispers in our genomes, as tools buried in caves, as skull fragments in museum drawers that still have more to say. The journey out of Africa was not a single road. It was a network of paths, some crossed, some lost, some still only dimly seen. And to understand how we finally became the only humans left standing, we have to turn to the other great archive of our past. Not just bones and stones, but molecules, our DNA. The next part of the story is written not in caves or deserts, but in the spiral code inside every one of your cells. Now, let the camera slowly pull away from bones and ground and turn inward, into you, because the next chapter of this story is not written in rock or buried tools. It is written in your blood, in the cells quietly repairing themselves while you sleep, in the spiral ladders of DNA coiled inside every one of your trillions of cells. For most of the 20th century, scientists trying to understand human origins were basically blind to this inner archive. They had fossils, stone tools, a few scattered clues from the earth. But the genetic story, the record of who met whom, who had children with whom, who survived and who did not, all of that was locked away in fragile molecules that decayed almost as soon as an organism died. Then, in the last 2 decades, something extraordinary happened. We learned how to read time. In ultra-clean labs, behind layers of glass and filtered air, researchers began coaxing tiny scraps of DNA out of ancient bones and teeth. Not just from fossils thousands of years old, but from remains tens of thousands, even hundreds of thousands of years old. They sequenced these fragments, stitched them together, and compared them to the genomes of living people. What they found did not merely tweak the Out of Africa story, it detonated it. You can think of ancient DNA as a time machine that does not take your body anywhere, but let your mind drift backward into the lives of people who have been dust for 40,000 years. Their genetic code is still whispering from inside your own, and those whispers tell a very different story from a nice, clean diagrams in old textbooks. For a very long time, the standard picture went like this. Modern humans evolved in Africa, left in a big wave around 60,000 years ago, spread across the world, and replaced everyone else. Neanderthals, Denisovans, any other archaic humans they met, they vanished, and we took over. No mixing, no entanglement, just replacement. Ancient DNA told us that was wrong in the most personal way imaginable. If you are of recent European, Asian, or indigenous American ancestry, there's a very high chance that somewhere inside your genome right now are stretches of Neanderthal DNA. Pieces of chromosomes that once lived inside the bodies of Neanderthals crouched around Ice Age fires, now quietly influencing your skin, your immune system, maybe even how you sleep. On average, non-African populations today carry about 1 to 2% Neanderthal DNA. That does not sound like much until you realize that it is not the same 1 to 2% in every person. Different people carry different Neanderthal segments. If you add up all the Neanderthal fragments scattered across all living non-African genomes, you recover well over a third of the entire Neanderthal genome. Some estimates push that number closer to half. In other words, Neanderthals are gone as a separate species, but genetically they are not gone at all. They've been dissolved into us. The traits they gave us were not random. Many of the surviving Neanderthal genes seem to be involved in immunity, skin, and hair. Things that matter when you step into new climates full of unfamiliar pathogens and unfamiliar sunlight. When our ancestors left Africa and walked into Eurasia, they met Neanderthals who had been there for hundreds of thousands of years. Neanderthals had already paid the evolutionary price for surviving in those environments. Their genes carried the receipts. So when modern humans and Neanderthals interbred, those genes were like a starter kit for survival in the north. Better resistance to local diseases, different pigmentation tuned to colder, dimmer, or more seasonal sunlight, inflammatory responses that help fight off infections, even if they sometimes make us more prone to allergies and autoimmune issues today. And Neanderthals were not the only ones whose legacy we carry. Far to the east, another group was leaving its mark, the Denisovans. For years, Denisovans were a ghost species. No complete skull you could point to in a museum. No dramatic reconstructions on posters. Just a few broken bones and teeth from a cave in Siberia and their DNA. When scientists sequenced that DNA and then compared it with people alive today, they found something astonishing. In parts of Melanesia, places like Papua New Guinea, the Solomon Islands, and surrounding regions, people carry up to 4, 5, even 6% Denisovan ancestry. Some indigenous Australian populations and certain groups in Southeast Asia also show strong Denisovan signals. That is 2 or 3 times the average Neanderthal contribution found in most Europeans or East Asians. It is as if Denisovans vanished from the fossil record, but stayed very much alive in the genetic record. And once again, the genes that survived were not random. Some Denisovan variants helped modern Tibetans live on the rooftop of the world, high on the Himalayan plateau, where oxygen is scarce and altitude sickness threatens anyone not biologically prepared. A key gene called EPS1, which helps regulate the body's response to low oxygen, seems to have arrived in our lineage from Denisovans. When you watch a Tibetan grandmother walking up a steep mountain path without losing her breath, you're seeing ancient Denisovan DNA in action. Other Denisovan genes appear to be tied to immune function and diet, helping people adapt to new landscapes, new parasites, and new plants. So we have Neanderthals contributing here, Denisovans contributing there, a quiet tapestry of ancient encounters written into our chromosomes. But the real shock came when scientists looked more closely at Africa. For years, the story went like this. People in Africa are purely modern human, while people outside Africa carry a bit of Neanderthal or Denisovan ancestry from ancient interbreeding. Africa was seen as the untouched source, the original stream before it split and mixed. Genetics painted a far more complex picture. When researchers examined African genomes in detail, they started noticing odd patterns, chunks of DNA that did not match typical modern human variation, and also did not line up with Neanderthal or Denisovan sequences. These segments seem to be much older, diverging from a main human line, perhaps 500,000, 700,000, even a million years ago. Yet they were still present in living Africans today. The best explanation many geneticists have come up with is that within Africa, modern humans, or their immediate ancestors, interbred with other, now extinct human lineages that we have never identified in the fossil record. Unknown cousins, sometimes called ghost populations, who left no recognized skeletons that we can confidently name, but who did leave children. And those children are our ancestors. Some studies suggest that certain West African populations might carry up to 2 to 19% ancestry from one or more of these unknown archaic groups. Not all geneticists agree on the details, and the exact numbers are still debated. Enjoyed the sleep story? Subscribe for more relaxing history and bedtime tales. Share your thoughts in the comments, and tell me what you'd like to listen to in the next video. We're working on the next part, and we'll upload it shortly. Good night, sweet dreams.